Okay, this is start of video XXX for Robert Koning, and what we're going to try to do is make a, we'll call it a punch and die set, to put a radius on the outside of some 2-inch pipe caps for his candlestick things. Now what we're going to start with is a couple huge blocks of steel, about 1.25 inches thick by not quite 2 maybe, and we're going to make them square so I can put them in a 4-jaw chuck. Now you wouldn't have to get this precise, of course, for what we're doing here, but I'm going to set the two on top each other, and this is a height gauge. It's not a real expensive one, but it's plenty good for what we're doing. So you run this down. This is a carbide scribe over here on the end. You simply run this down until it hits the top. Okay, and then you zero this out. Alright, and when you read it, it's going to read 3.5 inches. Okay, so now you move that out of the way. And I've already put bluing. Now this is a granite block it's setting on, and you know, if you want a precision one, you're going to pay thousands of dollars, and it'll be made by Starrett or someone like that. But anyway, I've already put bluing on here, so now we know the dimension from left to right. Okay, so now we want to mark it here to make a square. So we take this, and that carbide easily scribes the steel. Okay, so now when I cut this off, I'll cut it off outside of that line and then square it up in the milling machine. Then we'll have a block that's square. Alright? So now, while we're at it, we can take this dial gauge, and I'm going to have to, I can't really read it with my bifocals. But anyway, I have to get it down to 1 3/4 inch. Yep, I'm going to have to get it up out here where I can see it. 1/750. Okay, so now what I want to do is just put a short scribe line down below, like so. And what that did is that gives us, when you hold this thing up together, which weighs about 6-7 pounds, I've got a scribe line, and that's going to be the center when I get it chucked up in the 4-jaw chuck in the lathe. Alright, so now I got to go listen to the bandsaw for a while, cut through this stuff. Take care. Okay, Bob, after about 20 minutes with this exceedingly dull milling machine cutter, I've managed to get these two things to approximately the same length. This will be the last cut, and this is what we're going to take this cut going backwards, so you got to be careful, especially on a small milling machine, how much cut you take, because it'll try to run with the bit. It's like running a router backwards on a piece of wood. Sometimes it'll pull the router right out of your hand. Okay, Bob, we got them lobbed off to within 40 or 50 thousandths of an inch on the bandsaw. But this is one of the few bits that I have that has the depth to cut it all at once, and I've used the hell out of it for years, so it doesn't like cutting this steel. Anyway, this one end is done, and then we squared it up. Then I'm in the process of cutting this end, and I'm going to take what they call a climb cut. So the cutter is rotating this way. And what's going to happen, if you take a real heavy cut, it'll try to run just like a router does. It might, you know, on a router it could pull it right out of your hand. but it does give you a little smoother cut. So that's what we're going to try for. And especially on aluminum, it'll be nice and bright and shiny. And of course it would be better on this if the bit was sharp. But this doesn't have to be all that pretty, so after we get this done, the next thing we're going to do is we're going to line them up and drill some alignment holes all the way through them. We'll put a couple dowel pins in. That way every time we take this mess apart, it should stay lined up. Alright, so now we're through with the cut, and as you can see, it's pretty nice. Okay, so later. Okay, Bob, this is the top block for this setup, and this is the bottom one. And I've got them marked which edges go together. So we've got a bunch of holes here. Let me look at this thing. I'm not sure you can see them. I guess you can. Yeah. So far we got 4 holes in here, and the 2 outside ones, this one and the opposite one in the far corner, are just pilot holes. And I'm going to drill all the way through through this block and into the bottom block, and that's going to be for a 3/16 hardened steel dowel pin to keep all this stuff lined up. These 2 center holes, the top end is going to be drilled just quarter all the way through, and then the bottom half will be drilled with a number 7, so it can be tapped quarter 20. Okay, so I think I've told you this before. You're like your 1/8, your quarters, your 5/16, your 3/8 and all take a tremendous amount of wear. So I always take all these pilot holes were drilled with some drill bit, a couple sizes under a quarter, that rarely gets used for anything. So with all that said, these are going to be just drilled down. Of course, I won't drill down too far because I certainly don't want to drill into my vise. Now I'm only going to do this probably to the 2 center holes, because I really don't need to go any deeper, any bigger than those are. It would be just wasting a bunch of time. So we're about 1.25 inches deep. Deep hole drilling like this is always a lot of fun. The flutes don't carry the chips up very well. So anyway, we'll get to another spot. I'll give you another minute or two of what we're doing later. Okay, Bob, Cousin Les is out, and we got to talking about wild things and wild women and all that, and forgot to video a lot of this. So what we've done is the top part, we drilled pre-drilled the top holes, then we lined it up with another set of big jaws here and used some of the can't slip clamps and used a regular clamp and pulled the edges in so everything was centered and tight. So this top hole is drilled all the way through with a 1/4 inch. On down in for about 1 inch, we went ahead with a number 7 bit so we can tap it quarter 20. So that center one here and that one's done. These top holes were some weird size. 3 drill bit sizes under quarter, just so I didn't wear out my good bits. And that was drilled all the way through. No, I'm sorry, down within about half of an inch of the bottom. Then I went ahead and drilled with a bit 1 size under 3/16, and that was because we're going to use these 3/16 dowel pins. And then we reamed it with a dowel pin reamer that's supposed to ream about 1 to 1 1/4 thousandths of an inch undersize, but I'm not sure it was that far undersized, so one end of these may have to be Loctited into the block, and then the other end will be loose so you can actually get the parts apart. So now we're going to break it down and see if any of it works. We got to drill and tap the holes in this bottom piece for the 1/4 20. See you later. Okay, Bob, let me get you caught up. We've done quite a bit of work, and we've got the lower blocks drilled and tapped 1/4 20. We drilled these 1 drill size under 3/16, and then used a dowel pin reamer, which is 1/1000th or 2 undersize. And let me tell you what, I pressed these in. I was hoping I wouldn't bend them. But anyway, the bottom piece is done. So now we're back to the top. And these through holes here, these are done. And the cap-headed bolts will just drop in and thread into that. Okay, these are drilled to the same size as that press fit, which I can't have. So I'm going to start out with a 3/16 undersize, 1/1000th undersize reamer. So I've got that 1 under, 3/16, and 1 over. Now, a lot of people won't agree with me, but for a hurry-up way to do this, I just chamfered these holes just a little bit so that the reamers and everything will start. And in here, I've put one of my favorite little center finder things. Okay, and you have these, and by the way, so you just got to be careful coming down and just drop it into the hole, and then look for hangout front and rear and adjust it slightly. So I mean, that's within a 1/2 thousandth right there, and for what I'm doing, it doesn't make any difference. So then you can take that out and put it away. Then we're going to have to lower the table way down, and we'll chuck this. Well, maybe I guess we're okay. You don't often see me use a key type chuck, but I want to make darn sure that this doesn't slip. And this chuck really holds on. Now we're going to use some good tapping fluid. And we're going to slow the mill way down and feed it very gently. Now, as I said, that's a 1 under reamer, which I didn't expect it to pick up much. And it didn't. Just tiny little fragments. As you can see on my glove, that's all it picked up. Now, I'm going to shut the camera off for a minute. Well, I'm quite surprised, because what you saw what I took out of there, we got a nice fit now.
I wouldn't have said anything. Yeah, the mailman.
Okay, like I said, much to my surprise, this is an undersized reamer, but not quite as much as that pin reamer, and fits very nicely. So we're just going to go ahead and ream this hole the same way. And I can feel it cutting, not a lot, but... And by the way, never back a reamer up. It'll knock the edge off of it. Okay, so that should fit, that should work. We'll see in a minute. Well, it goes together very nicely, and we won't be taking this clear apart. So there seems to be a binding. Well, there it slid right off. I guess probably got a metal chip in there yet. But anyway, this really won't come apart. It'll just be loosened. So we set it on and it falls in place. We got the cap screws that'll tighten down and lock it, like so. So what we've got here is now a solid block of metal that can come apart. And believe it or not, that's all we were after through all of this. Later. Okay, Bob, here's that first piece finished. And this is an edge finder. And you push it off center a little bit so that it's not running perfectly true. Run up fairly good speed and bring your material over. Take it on the other side where I get my hand out of the way. And you're going to see this thing straighten up. Okay, so see it's running pretty true now. When it gets true, watch for it to kick one way or the other. Okay, see it pop over? Alright, now shut it off. Raise it up. And I'm going to lock the table because I've got a bunch of backlash in my compounds. I'm going to pan down here so you know what I'm talking about. Okay, so here's my mark right here. So I'm going to bring this table to the right. To do that, I go counterclockwise. So by turning it counterclockwise, and I got the table locked, now I can bring this to 0. There's 90 and 0. Okay. So now you have to remember that this centering tool is 200 thousandths in diameter. So I'm not at the edge of this. I'm 100 thousandths the wrong direction. So I have to turn it 100 thousandths, and we took the backlash out, so it'll be a true 100 thousandths. So now, if I had a pointer on this and brought it down, it would be right at the edge of this material. Okay, so I'm going to get this out so I don't break it. I have broken them. And I haven't ran away, I'm just trying to find one of my centers. I don't know where they all went to. Ah, here's one. This one will work. Okay, so I'm going to put a center in here now, a spotting center for drilling. And you'll see why after a bit, not tonight, but okay. So now when I bring this down, the tip of that is right at the edge. Okay. So now to get to the center of this block of steel, this block of steel is 3" dot 256. All right. So I have to come this way 1" 628 thousandths. So 1 inch, I'm going to move this camera a little bit. I might make you dizzy. But just so you have some perspective of what's happening here. Okay, so I got to go 16 turns plus 28 thousandths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 28, 10, 28. All right, so now we're right in the center of this, left and right. And I already got a groove through the center, so I know where that's at. So I'm just going to eyeball that, because for what we're doing, this is all so I can set it up in a 4-jaw chuck. So we come back to here. So I know I had my arm in the way half of that time, but nevertheless, I'm going to go ahead and drill that on in a little ways, and then we'll have a center, and then we'll use that in the metal lathe to center up into the 4-jaw chuck. Okay, Bob, I'm not sure if I've ever shown you the correct way to remove a Logan chuck off a threaded spindle. With the hood open, pull out this lever down here. Normally, you would pull this button out here and engage this to engage the bowl gear. But what you're doing right now is you're locking the headstock so it cannot move. Now, you've got to be careful how much pressure you put on it, because these teeth on this bowl gear are cast. They're cast iron. But anyway, take a stick and put in the jaws, open the jaws a little, and then give it a quick snap. Okay, and it'll pop it right loose. Now make sure and stick something up in the through hole and just spin your chuck, and it's off. Now I always put a board down here. Just in case I drop something. Because believe it or not, the chuck will really screw up the ways. Now while you got this off, make sure your threads are clean. Take the same stick, get your 4-jaw chuck started. It's a lot lighter now, so it's a lot easier to handle. And spin it on a little bit, get it up close to where it's tight. Take it slow, you'll feel it hit the spindle. Okay, now back it up just a little and give it a quick spin. Alright, you're good. Undo this over here, and this is spinning and ready to go. So you've just changed the chuck. Later. Okay, so to get a better bite on this block, the way the jaws were facing in, it's made for during small work, okay, in your 4-jaw. But these jaws, you simply back them all the way out, use the same jaw. When you get it out, don't drop it like I just did. Raise this out, turn it halfway around, just put it back in, and start the threaded part back in here. And then crank them on down. Alright, so now you can either grip in here or in here. So you got two different areas you can grip in. So this is going to set in here like so. So just to get it close, there's rings going around this chuck. So I'm just going to bring these jaws in to the third ring. And I don't know if you can see the rings or not. Oop. Maybe we're not going to do that. I think we're going to have to turn it on the center. All right, I'll get this closer and be back. All right, Bob. Once again, I'm working my arm through the tripod, but you remember the peck hole, the center hole I put in. So what we're going to do now is bring this up. And you can't see it, but I need to move this whole unit this way. So I'm going to loosen this a bit, turn this, and push this down. And now don't tighten them real tight. Okay. Loosen this, and as I feed the chuck in, the tailstock, I can feel it, so now I'm just going to tighten that one just a little bit. Tighten this one a little bit. Make sure this one's tight a little. And make sure this one's tight a little. Then I'm simply going to turn about 1/8 of a turn on each one, all the way around. Now this time I'm going to reef down on them, because I don't want this thing going anyplace. And by the way, on a 4-jaw chuck, you can put twice the pressure on your workpiece as you can on a 3-jaw. Alright, so there you go. And we'll turn it on. Running fairly straight, or at least good enough.
Good morning, Bob. Well, I'm way too slow at doing this to put it all on camera. But I showed you the quick and easy way to get, this block of steel within, 4 or 5 thousandths or whatever. But a good way to do it is when you're working with square stock. You still do that a little peck in the pilot hole for a center. But you put a dead center in the tailstock, which means one does not have ball bearing in it. And then you take another center that has a center hole drilled in the back of it, and mount it between this center and the workpiece. So this center right here, it doesn't rotate. But what it does do is, as you turn the piece of work in your headstock, you can watch this needle here, and right now we're within a 1/2 of 1/1000. So what discourages most people from doing this is they can't figure out which way the needle is telling them to move the jaws. So all you're doing is you're moving the back jaw, the front jaw, a combination of this jaw and this jaw and these two to get it centered. So what I found out over the years is if you'll take and put your 0, let's say on this side, when the item is out around this way, so this needle moves this way when you're turning the piece, that means it's too far this way. And so you simply loosen the back jaw, tighten the front jaw. Now if you put the 0 on the other side, everything would be just the opposite. So I always find out that if I put the 0 on this side and work off the 0, then when I rotate this thing, it works out easier for my pea brain. That's it for this morning. So Bob, a little recap. We got this centered up the best we can get it in a 4-jaw chuck within about a thousandths, which doesn't need to be that good for this. All right, and I've got a carbide tool mounted in the tool post, and I've got the cross slide in the bed of the lathe locked. Okay, I've got the thing in automatic feed, and we're going to feed in this way, and that's the way the radius on the carbide tool is made to cut. You shouldn't really cut coming backwards. You can take maybe a thousandth or so, but it really doesn't like it. So here we go. And we're going to engage the compound, and you'll see it start to move. You hear some clicking at first, which is the outside edges that are square, so we haven't hit the round body. And I have it running pretty slowly. Because you have to remember that there are feet per minute cutting speeds that come into play here. And the outside of this, being 4 inches almost in diameter, or it is, we're way above our cutting speed where we should be. And when we get to the center, then we're almost at 0 feet per minute. So what you do is kind of pick a happy medium and see what happens. We're only taking off about 5 thousandths, and I just want to get the bottom flat. Not that it has to be perfectly flat, but we're going to make it that way. If I were good at editing this, I would cut out about 80% of this and just give you some short little blurps, but I'm not. So you can fast forward it. You're starting to hear the lathe change sound a little bit. So now we're actually on the center part, making full contact. I won't bore you with all of this, but this will be our final cut probably actually I guess this is going to be the bottom. The next step will be to cut the square part off of a good deal of it, probably about a 1/2 inch, so I can get it into a chuck, a 3-jaw chuck. Okay, that's enough of this. Okay, Bob, I'll only give you a few seconds of this because I don't even like doing it, so I'm sure you're not going to like watching it. A couple things when you're doing square work, okay. First of all, always make sure all your clearances work before you turn this thing on, because believe it or not, the bit sets out here, so you make it miss all the tool post holder, you know, the jaws of the chuck coming around and everything. But what you don't realize is that the jaws are hanging out further when they're dead center, which will hit this back protector here. Set a stop over here so you can only go in so far, and take everything slowly. So we're only cutting about 15 thousandths, and this is as bad as it gets on a small lathe. You can hear all the banging, and if you could had your hand here, you'd feel these compounds and cross slides moving around a little bit. So I've already been about 15 minutes to get it this far, probably another 20 to get it into where it's into the round part, which then it'll turn nicely. Now we're going to hit the stop in here in just a second, and there we are. And then we back it out, and then we come in another 15 thousandths or so and do it again. There you go. Okay, Bob, I sent you the final facing cuts on here where it'll rest against the 3-jaw chuck, and here where the chuck will grab it. And right now all we're going to do is just do a simple break the edge so nobody gets cut on this thing, because it's pretty sharp. Doesn't take much, just like that, and we're done. So the next thing we're going to do is we're just going to bore a hole through here. We'll probably start with a 1/4-inch bit and drill a hole through the inch and whatever it is, 1 1/4, and keep going. The biggest bit I have is 1 inch, and it pushes this lathe hard to use a 1 inch. So then after that, I'm going to turn it around and probably just start boring the hole with a boring bar. So we're gaining. Okay, here we're making our way through all the gyrations to get a big hole in this thing. It's about a 2 1/8 inch hole. So far, here's what we've done. We did 1/4, 3/8, half, 3/4, 7/8, and now we're on 1 inch. And trust me, this is going to get noisy, because to get the power I need for a 1 inch bit, I have to run it in back gear. And these are all square gears like old transmissions were years ago. So every once in a while you got to bring it out and clear it and oil it. On these big bits with a good pilot hole, I do it about every 1/2 inch, and that's 5 turns on the tailstock. It's a 1/10 of an inch per turn. Well, Roberto, we're getting down to the last few cuts here, and when I say few, I don't know how many hundred of these damn cuts I've made to get this thing this size, but we're going to take about 15 thousandths, and I'm using self-feed, running in a back gear, so it's making a lot of noise because this lathe doesn't have the power
to cut this 2-inch hole without slipping a belt. Okay, I'm not sure that you've ever seen one of these, but it's an inside mic, and you simply slide it up in here. Of course, you're going to get the carriage out of the way and everything, and open it up a little at a time. Okay, that's pretty close to it. And when you get it in there, you're supposed to rock it to like that. All right, then you take your regular mic and you take a measurement, and then with your same regular mic, you mic the outside of the copper tubing cap. But I'm probably not going to make it a snug clamp fit, because what I'm finding is these copper caps are not different. They're all different. So later. All right, Bob. I spent the morning so far, and you can see I have a pretty good radius on there, and it's actually about using my Sears and Roebuck radius gauges, and this is what they look like. And this particular one is a 5/16. So the only portion I can use to measure it is right there. And when you stick that up in here, I know you can't see it, but that fits it pretty well. So we're almost at a 5/16 radius. And of course, what I have to do is match that on the plug that's going to be pushed in. I'm going to try to take one final little cut. I'm not happy. I've got a lip clear up inside here where it goes into the straight wall. I'd like to get a hair more bevel on it, but it's pretty tough looking up inside of here and seeing where you're at. And I'm sure my head's going to be in the way of this camera, but I'd rather have that happen than screw up what I've done here. Okay, and I think you can see the difference in the colors. So what I did is extended that radius a little bit further down in the hole. Now I'll go ahead and polish this up, and then I'm assuming we'll probably have to lubricate it when we put it in the press. So we get this is pretty well done. Polish it out, get it out of here, and then we'll figure out what we're going to do on the plug later. Well, Bob, this will take a while. I'm trying to lob off 2 inches of 3-inch diameter material to make that top plug out. Okay, it took about 15 minutes to lob that piece of 3-inch bar stock off. I have no idea what it is. I took an old carbide insert and reground it with a small diamond wheel, and it's actually doing a very nice job. This is about my third cut, and I think that I'm going to have this in square parallel. I did put a dial indicator on it, chucking it in the lathe because it was running about 10 thousandths out, and so we center drilled it, so when I'm turning to the center like I am, it has a place for the bit to go and stop. So we're gaining on it later. All right, Bob, I've kind of guessed a depth that I want. I'm 3/4 inch maybe, and then when we get down closer to the right diameter, which is 2 1/8, then I'll start working the radius into the picture. Not quite sure how all that's going to turn out, but to cut this stuff, this is 3-inch diameter, and remember what I talked about, feet per minute and all that on steel and etc. Running not in back gear, I could only do about 7 thousandths of an inch and kept throwing the belt. So now I'm running in back gear, and with back gear I can pull 20 thousandths off each side, so I'm taking it down 40. First, it's quite noisy, and I'm using a lot of oil. And you got to stay away from those that ribbon coming off of there. These particular bits, the carbide cutters, do not have what they call a chip breaker. Now when you get down close to the shoulder, take it out of the automatic feed mode, and we're simply going another 20. A little bit more oil. And off we go again. This will probably take me 2 hours to get this down where I want it. All right, Bob, we got the radius, the inside radius cut, and now we've center drilled this. And I'm running regular, not in a back gear, so I can't take but about 4 or 5 thousandths cut. And plus I'm not chucked on much material back in the back. And it wouldn't take much to hang a bit and cock this whole piece and probably break a carbide insert. So I'm taking it rather easy. And when we get this spaced across this way, we'll go ahead and clean up this outside here and then break the 2 corners where the edges, outside edges here, are not sharp. Now you may wonder why I'm doing this. Well, it was really crooked, and I didn't want it, when we put it in the press, I didn't want it to press in crooked. It'll be hard enough to try to figure out all this. We'll see what happens later. Well, Bob, there's about the 8th or 9th tray full of razor wire. That's about 6 inches deep. Getting ready to clean up the lathe, I think, for the last time. Here, I think, is the finished punch. A lot of unknowns to me is like how far to make this shoulder to start in. Should it have been deeper? Well, if it was too deep, it would bottom out in the bottom of the cup. Is the radius the same on the inside as it is the outside? You know, there's a lot of engineering questions that I can't answer, but we'll give it a try. Okay, so, Brother Bob, the process does work. I need a couple refinements. What I found rather quickly is one of the big keys to this is getting the whole unit positioned perfectly underneath the press ram. Because if you're off to one side, it pushes one side down further. So this is what's on the end of my ram. And so I'm turning the top die to where this will go up inside of it. So I don't know if I've ever shown you this before, but a lot of times when I'm going for bigger holes, I use a milling machine end mill chucked up in the lathe that cuts a nice flat bottom hole. Now it does a little chattering once in a while, but we'll see how it goes. We may not have enough power without going into back gear. Now this is a 7/8 end mill, and I'm going a 1/2 inch deep. So that is 5 turns on the hand wheel, so you don't have to measure or anything. Each turn on the hand wheel is 1/10 of an inch. Now I really should back this out and put a little more lube in it, but I'm about to bottom out here. I'm just giving it little bumps. Okay, so there we are. Now we have a 7/8 hole. Now I'm going to try to locate my 1-inch one, which I don't know what I did with it, but I'll find it. All right, Robert, here we go. This is, I think, the next to the last clip to be added into this video. So what we've got is the punch mounted up here on the press, and it's excuse me. When I may have a hard time getting that off. I don't know why I turned it as tight as I did, but anyway, it's kind of stuck right there right now. So the first thing we're going to do is take some, this is synthetic grease, and it's really good stuff made in the U.S. And of all places, it's sold at Harbor Freight at a quite a bit better price than normal. And we just put a ring of this around the punch up here, just to kind of help things slip and slide a little better. Then of course you got to get it off your fingers because it's transfers to everything. All right, then the next thing we do to get the cap up high enough. All right, so we've got this. I'm putting 2 big spacer washers in there, and it's simply cheating because I'm just too lazy to machine all that off the back edge. It's a real pain to do. Okay, so you drop those guys in, put the cap in. Now if you see this kind of rocks a bit, and I'm not sure what's going on. I think I bent the press when I was working on Robert Clark's stuff. So anyway, I got this hooked up to the air, and we're just going to bring it down. Oh, well, at least that comes off. I didn't think that would come off that easily. Okay, so now we're in the hole. All right, now what I found is it might be because the press is bent, I don't know, or whatever, but I'm simply going to turn this thing halfway around before I totally release it. All right, now, without moving it, what I found is that it kind of leaves because of my angles, it leaves a little up kick. So I'm putting this on it, trying not to move anything, just so it's all centered. Now that's got a lot of pressure on it, Bob. That's probably 12 ton. So we raise it back up. Take this piece off. And here's the formed piece. And it's pretty flat. Okay, so the one thing I'm going to do while this is still in here, I'm going to take it in and remount it in the lathe on this back part that I spent all that time turning for the 3-jaw, and I'll polish it. All right, what we're using here is just some simple fine cut rubbing compound for automotive. Putting a little bit on the rag, maybe. Instead, maybe we'll put some on the floor where it belongs. All right, running the lathe up at a pretty high speed, but make sure and keep your fingers away from all the chucks and that spinning. And only takes a minute or two. The bottom is the hardest place to get. Then take a clean rag. Not sure how well you can see it, but anyway, that's pretty good, pretty good. That's about it. The conclusion of this video.